Hello everyone, and welcome to the show. Today is Saturday, May 16th, 2026, and I am your host, Sannoani Kane, bringing you another fun and exciting broadcast. I'm just so happy to be here with you all today, and I hope you're having a fantastic weekend so far. Today we have a really special topic to dive into, because I am introducing a super trending article from the archive. And it is all about some cutting-edge artificial intelligence. What is right, we are going to talk about a brand new research paper, and I'm going to explain all the cool details to you. The title is SpeakerLLM, a speaker-specialized audio clone for speaker understanding and verification reasoning. The kernel is Pittsburgh-Oregon 5.15,044. It is long, but do not worry at all, because I am here to break it down into bite-sized pieces so we can understand exactly what this amazing technology does. To get started, let us talk in detail about the problem that this paper is trying to solve. You know how nowadays we have all these smart devices, like smart speakers, skin-less wearables, and even conversational robots. Well, in these audio-first environments, voice is the main way we interact with the machines. Because there is no screen to tap or keyboard to type on, the artificial intelligence needs to really understand who is speaking in order to authorize users and personalize the experience. But here is the catch. Traditional speaker verification systems are kind of limited. They just compare two voice recordings and give a math score to say if it is the same person or not. The problem with that is they do not explain why. If the system rejects your voice, you have no idea if it was because there was too much background noise, or if the room was too echoey, or if it genuinely thought you were a different person. On the other hand, we have these new general audio language models, but that only give very basic descriptions, and they really struggle to organize specific speaker information. They might know if a voice is male or female, but they are pretty bad at picking up fine acoustic details, like the exact pitch or the brightness of the voice. So the researchers created SpeakerLLM to fix this huge gap. SpeakerLLM is a specialized framework that does not just give a simple yes or no, but it actually explains its reasoning in natural language. It looks at a single voice recording, understands the speaker profile, figures out the recording conditions like noise and echo, and then compares it with another recording to see if they match. The most amazing part is how they built the technology inside. They designed something called a hierarchical speaker tokenizer, which is a fancy way of saying it looks at the voice in two different ways. First, it creates an utterance level embedding, which is like a big picture summary of your identity and profile. Second, it uses frame level features, which generate tiny, fine-grained acoustic descriptors like your exact pitch and the timbral brightness of your tone. By combining both the big picture and the tiny details, the language model gets a perfectly complete image of the speaker. That is right, it is so much smarter than just looking at the overall sound. They even trained it in a really clever two-stage process. Stage 1 teaches the model to understand basic things, like answering questions about the speaker profile and the environment. Then, Stage 2 is where the magic happens, because it teaches the model how to do verification reasoning. It outputs its final answer in 3 clear blocks. First, it gives the environment status, telling you if there is a lot of background noise or reverberation. Next, it gives the profile compatibility, comparing the age, region, and voice characteristics of the two recordings. Finally, it gives the decision, explaining clearly if the speakers are the same or different. They even included something called reversal cases in the training. This means it taught the AI not to be fooled by two people who sound similar. If two people have the same age, gender, and regional accent, normal AI might just guess they are the same person. But SpeakerLLM learns to dig deeper into the latent identity cues, and it can correctly state that even though the profiles match, the actual identities are different. Now, Let us compare this with other technologies out there. When you look at general audio models, they get around 20 to 30% accuracy on tricky things, like identifying pitch or room reverberation. But SpeakerLLM jumps way past that. It improves pitch understanding to over 72% and gets over 50% accuracy on tricky 5-way noise classifications, compared to older backend scoring systems. This is a massive leap, because it actually talks to you and explains itself, making the AI completely transparent and trustworthy. So how does this apply to our everyday life? I have at least 3 specific application examples to share with you, based on the incredible content of this paper. First of all, think about smart home security systems. Imagine you walk up to your smart door, and you ask it to unlock, but there is a loud lawnmower outside. A traditional system would just beep angrily and lock you out, leaving you confused and frustrated. But let's click on this. It could say, your voice profile matches, but the environmental noise is too extreme for a safe verification. Please step closer to the microphone. This makes smart home security so much more user-friendly and less annoying. Second, this could completely change customer service call centers. When you call your bank, they always have to ask you a million security questions. If they use SpeakerLLM, the system could automatically verify your identity while you are just saying hello. If the line is bad, the system creates a structured text log for the human agent, saying the caller matches the profile. But there's heavy phone distortion today. This speeds up the process, keeps your bank account secure, and gives the bank a perfect audit trail of why you were approved. For the third example, let us think about personal AI assistants and screenless wearables, like smart glasses or smart earpieces. Since you cannot look at a screen, the AI needs to know exactly who is wearing the device. If your phone puts on your smart glasses and tries to read your messages, SpeakerLLM will instantly know it's not you. It can analyze the tiny frame-level details of the voice, realize the temporal brightness is totally different, and refuse to read the messages aloud. Plus, it can adapt its own conversation style based on your current voice. If it hears that your pitch is lower than usual and you sound tired, it might offer to play some relaxing music instead of reading emails. It is just so incredibly impactful for the future of personalized AI. Reading through this paper just makes me so excited for the future. The fact that we are moving away from simple binary computer decisions and moving towards artificial intelligence that can actually reason and explain is just mind-blowing to me. The researchers really did an amazing job separating the profile evidence from the final same or different decision. It proves that we can have advanced biometric security that is also polite, conversational, and easy to understand. I hope you found this deep dive as fascinating as I did. Thank you so much for tuning into today's broadcast and listening to me ramble about this awesome tech. I will be back next time with even more fun and trending topics. Have a wonderful rest of your Saturday. Stay curious and keep smiling. Bye-bye, everyone.